Part of Jim's success is the fact that he's an iconoclast. Great scientists are creative people.
Jim's lab has a feel of being like a pirate ship.
Jim theorized that tumors have evolved to trick the immune system.
At the time, it was a crazy idea.
This constituted a real breakthrough.
I knew that this is a way to cure cancer, and I'll be damned if I'm gonna let that just lay around.
For the next decade, he had one goal: to get that made into a drug for cancer patients.
It was just no, place after place after place.
Many of my colleagues said, this will never work.
My mother sat on the bed with her and held her hand while she died. I found out later that it was lymphoma. When I was first told I had prostate cancer, I was terrified because it was a week after my brother had died.
BMS was not sure they were going to take it at all.
I must admit I was apprehensive.
His experiment in this was to just keep fighting, to say, there's something here.
He's willing to do it in the face of his colleagues not necessarily believing him.
He wanted to stay on the scientists, he wanted to stay on the FDA, he wanted to stay on Bristol Myers Squibb.
I need to get it into people. I need to get it into patients.
I got a phone call from the radiologist. He goes, what did she get? All the cancer went away.
Until then, it was just a concept. She was the first patient I'd ever met.
How in the world are you supposed to adequately thank somebody that without them, you wouldn't be here?
That makes it all worthwhile.
It takes a really powerful idea combined with someone willing to push it forward to make it happen.
The number one thing I learned was how important it is just to persevere.
We knew we were changing the world.
May I ask you to step forward to receive the Nobel Prize?
All right. Thank you so much for your interest in using Jim Allison Breakthrough for your classroom. I hope you enjoyed the trailer. My name is Ann Phillips. I work with Uncommon Productions, the producers of this film, and I've had the pleasure of executing the education program and work with some really amazing teachers who I'll introduce to you shortly. This truly inspiring story chronicles Nobel laureate Dr. Jim Allison in his quest to discover a cure for cancer. And with thanks to Skyhawk Therapeutics and Dragonfly Therapeutics, free screening licenses have been made available for educators who wish to use the film either as a general way to teach about basic science and the research process, as well as the specifics about some of the science in the film. And over the summer, we collaborated with 3 amazing teachers to create a companion toolkit to the film that includes lesson plans, labs, worksheets, discussion questions, and career exploration activities that can all be used in the classroom. We've also added NGSS and AP biology standards alignment for the activities. And since many of you teachers are not back to in-person teaching yet, the film can be assigned to students virtually, as well as many of the activities. So it was truly a pleasure to work with Amy Kelly, a high school biology and forensics teacher at Manuka Community High School in Manuka, Illinois. She'll walk you through the introduction to cancer parts of the toolkit. Jeff Grant, a high school science teacher from Downers Grove North High School in Downers Grove, Illinois, will explain the immune system lessons and workbook he created and illustrated. And last but not least, Richard Benz, a retired biology teacher from Wycliffe High School in Wycliffe, Ohio, and current science education curriculum advisor with Lake Metro Parks in Lake County, Ohio, will take us through the medicinal mining lab activity and the FDA process parts of the toolkit. So without any further ado, it is my pleasure to hand things over to Amy Kelly.
Hey everyone. So I wanted to first start by explaining why I was so inspired by this project and this documentary. So first of all, my dad is currently surviving leukemia. And so we've had a lot of conversations about the different therapies that he's had to undergo. And I know a lot of my students have experience with cancer in their families. And so I wanted to develop some materials that would help kids understand some of the basics of cancer. Let me go ahead and share my screen. So you can see for part 1, we have a set of discussion questions which are designed to go along with the documentary. The first activity is an inquiry activity, and it's designed to help kids learn a little bit more about the basics of cancer, but it allows them to do so in their own way. It ties in some modeling and incorporates melanoma, which was one of the main cancer types discussed in the documentary. One of the things that we have set up for particular activity is some collaboration with peers. So peer-to-peer learning is very important with this activity. The second activity that we developed was some practice on the cancer and cell cycle. And for this, there's a passage and a diagram, and it allows the students to learn more about how cancer cells are essentially regulated by a cell cycle, or maybe they're not being regulated properly, to be more clear. The last one is a cancer and cell cycle lab, and it gets into things like apoptosis and Hayflick limit, looking at cell lifespan. And it gets into some of the similarities and differences between cancer cells and normal cells. It allows the students to look at some cells under the microscope, and we have some great discussion about staining methods and pathology when doing this activity. This is something you could do remotely too. You could always provide them with pictures of the microscope images and allow them to do their analysis that way. There's a little bit of math, computational thinking here, as well as some analysis and post-lab questions. So I think that's about it for part 1.
So I'm part 2. I'm Jeff Grant. As Ann introduced me, I teach at Downers Grove North High School. I just saw this come through, as I'm sure a lot of you did, through National Association of Biology Teachers, and I watched the show, and when asked to possibly create some material, saw the video, I just had one of those aha moments that it was like, this could be something really cool for kids to do, cell communication and immunity. Oftentimes, activities that students really don't understand very well. And for me as a teacher, just needed more resources to give examples in the classroom, both AP Bio, and I teach anatomy as well, and principles of biomedical sciences. In all 3 of those courses, this would be activities that I selfishly designed for myself, but would be useful for any class that is studying any of that cancer, immunotherapy, or cell communication stuff. So let me show you real quick what this kind of looks like, and walk you through at least my mindset of how I was looking at this. So I called it flags, tags, locks, and keys, looking for something creative. And when a student goes through this, we kind of set it up as, hey, here's how cells communicate, right? A little bit of humor thrown in there that they use cell phones, right? And they have a celebration. But what it really comes down to is flags and tags on cells that allow them to talk to each other, quote unquote, talk to each other. So we go into a little bit of the real science behind it, and how the fluid mosaic model, the outer surface of the cell membranes allow for those flags. And then we kind of anthropomorphize it, right? And allow the cells to become these human entities, so that students understand that when these flags get made, this is how they chemically talk to each other. So we're asking students in this situation to think about how body responds in homeostatic situations, like if it gets hot outside, sweat glands and they need to release sweat. How does that happen, right? So what is the generic response? And then from there, we could take it to the point of, hey, there are these molecules that cells communicate, and they don't use microwaves like a cell phone does. They use hormones. And so we have students do a little bit of a lookup and ask them to make sure that they're using credible sources. So they have the information source section. And then after that, they go into, like trying to model what this situation would end up looking like on the interior of your cell. So the immune system fighting against the army of not you. And that's really what it comes down to. And Dr. Jim Allison in his video talks about how the whole process of immunotherapy is just activating that immune system so that it can work better to fight cancer. So students in this activity take in these cartoons, learn a little bit about the immune system, and then make predictions and justify your predictions. So here we have multiple different types of nefarious invaders, and they have to think about what kind of antibodies would cling to those antigens that are sitting on the surface of these cells. And from there, then we dive into this whole negative feedback system and how Dr. Allison figured out that this negative feedback system is one of the key things for fighting cancer, and how they can end up making this immune cell therapy to fight, to help your immune cells fight the actual disease. So some of these images are taken directly from the documentary, and then we try to obviously connect it to the cartoons that are within the activity. And the kids throughout this whole activity are basically doing what I would call real science that doesn't have specific answers to it. Even though we provide an answer key for you, there's a lot of flexibility in correct answers, because that's how real science is. The key is that we're looking for the students to justify their answers with evidence. And that's kind of the key for that second activity.
Great, thank you, Jeff. You can take it away, Rich, if you're ready.
I think so. Yeah, I'm Rich Benz. I'm a retired biology teacher, but when I'm certainly active in NABT, and when they offered to stream this film Breakthrough, I jumped right on it and was blown away by the film. One of the big things that I always do in my classroom, and I teach teachers now and teacher workshops, as Ann mentioned, to kind of bring nature to the schools. And so I'm kind of the person that wants to use what I had done for 34 years in the classroom and bring it to other classrooms. So I immediately got in touch with Ann and said I'd love to be involved in helping to develop some resources for the use of this film. So let me share my screen. And I worked with on 2 different lab activities, and we'll go to part 2. One of the things that I was impressed with in the film was how the process of science was exemplified. And that's something that when I teach, I really like to talk about the process of science. And throughout this film, you're not only seeing the development of a major breakthrough, but also the how science actually is done step by step. So the first activity that I developed is what I called mining for new medicines. Early on in the film, Dr. Allison talked about when he was a grad student that he was looking for a product called aspirinogase, which was being used to fight cancers, to fight leukemia in children. Not totally successful, but having some success. And he was gathering various bacterial enzymes from nature. So I thought, well, that's an activity that students can do. So we basically are looking at soil microbes. So what the students are doing here is that they're harvesting various soils from their own environment. Okay, so the mining for new medicines. Can you see the screen at this point?
We can.
Okay. So basically what the students will be doing in this lab activity, and it is a wet lab where they get soil from various environments, their backyard, the schoolyard, and they're going to try to see if there are any natural antibiotics that are being produced by the soil microorganisms. I actually borrowed the idea for this lab from a group that works with soil, and it's very, very simple. Basically, you're going to culture E. coli. The protocol for doing that is listed in the lab activity. Once you've cultured the E. coli bacteria, and this can be E. coli that you purchase from a science supply house so that you know that it is a safe E. coli. The E. coli K12 is one that is non-pathogenic, and I gave you references on how to get that particular strain of E. coli. But truthfully, any bacterial colony would work. And then you're trying to see if you can create zones of inhibition from these natural soil antibiotics. So what we're trying to do is kind of replicate the process that Jim and other graduate students did to try to find some natural products. And then there are a series of extension activities and discussion questions, a whole series of references for the activity. And from the Soil Science Society of America, you can get the further references to that. So that was the first lab that I developed. The second activity is actually in part 3, and let me go back to that. In watching this film, the current situation that's going on with COVID-19 jumped to the foreground in my mind, because throughout the film they talk about how do you go from a breakthrough idea to the development of a drug that is available to the medical community and the general public. And so the process that you have to go through, the FDA process, to me is so current, because that's what we're talking about on a daily basis with the pandemic. And so I did some research on the FDA drug development process and put together this activity. So there's some pre-lab questions about drugs and medicines and how they impact us on a daily basis. A little background from the film itself on the process that Dr. Ellison and his team had to go through. One of the things that was amazing was the length of time that it took to actually get FDA approval. And so I make it so that the students have to discover some of the difficulties in going through the process. We call it going down the pathway. And so basically that's what the students will do. They're going to research the FDA process and fill in this chart that takes them through the various steps that both the breakthrough team had to go through, and of course the same steps that the COVID-19 research is going through. Within that, one of the things that's being talked about in great detail is the trials and how many people are involved in all the trials. So I have the students investigate that. And then finally, one of the points that I think needs to be made for our students is that the development of medications is not just a United States process, it's an international process. So I had the students do a little research on finding how are drugs and medicines developed throughout the world, and are there other processes in addition to the FDA process. So that's the second lab that we developed, and I think it really fits into what we're all dealing with on a daily basis with the pandemic. So I think that should be about it.
Thank you everybody for walking us through those activities. That was awesome. Yeah, they're really fun. And since April, we've had over 700 high school teachers and college educators sign up to use the film. So I would like to, before we close, take a quick moment to share some of those testimonials with y'all. Pull this up. So here we have a biology major from Louisiana Tech University who says, being able to see curiosity develop a question that changed the lives of many inspired me to continue being curious. Dr. Allison just wanted to know the what behind T cells, not knowing what would come of answering that question. As a student, I find myself inspired to keep asking questions and being curious while allowing my education to support those questions. Dr. Angelica Antoni, a biology professor at Kutztown University, says, this film achieved in one afternoon what I spent the entire semester hoping to. Rachel Norris is a biology teacher in Little Rock. This film portrays all of the frustrating and wonderful aspects of science through Dr. Allison's journey and sheds light on the power of the scientific method and its life-changing outcomes. And finally, Cheryl Lenz, a science teacher in Saratoga, says, Breakthrough shows the process of groundbreaking science in very human terms that students can relate to. It is truly inspiring. So with all of that, I just really want to send my sincere gratitude to Jeff and Amy and Rich for your time and your expertise to develop these resources. And I invite everybody who's watching this video to visit breakthrough.com, visit the For Educators page to explore the activities online. You can sign up for a free screening license, get your copy of the film and a copy of the companion toolkit. And you can contact us at any time at breakthrough@uncommonproductions.com. So yeah, thank you so much to all of you for joining.